Good morning, friends. Now, our today's topic is Pascal's law. See, now, what is Pascal's law? That says pressure intensity is same in any direction and transmitted equally in a closed volume. So, we'll write here. So, we'll see briefly about what we have written. If we take an example for intensity of pressure that is same in any direction, if we can understand it by a simple example, we can remember it for a longer time. So take an example like, see, in our childhood days we have done some funs. Take a balloon and in that balloon pour some water. This is water and we pour that water in the balloon. Now, after pouring water in the balloon, if we pinned the balloon, or we may say if we are going to leak that balloon, the water comes out through this pinpoint like this. So what we are saying, after the pouring of water, or we may say when water comes out through this leakages, suppose we are saying for the our imagination, or we may say for our analyzing purpose, this is px, this is py, and this is pz. Px is nothing but pressure intensity, or simply we may also call it as pressure. So Px, Py, Pz are same in any direction. Means intensity of pressure of water coming out from the balloon is same in any direction if we maintain the height of water. Because the height is reducing, so pressure intensity changes. If we are able to maintain the height of water constant, in that case the pressure intensity or the pressure is same in any direction. So this is the example for our first line, that is intensity of pressure is same in any direction. Now transmitted equally in a closed volume, if we are going to see an example. Now all of you has come across the car washing. Now what is the application of Pascal's law? There you came across how they have applied the Pascal's law there. Again we are going to see by an example. Now if you observe, these are the pipes, or we may say, now this one is the ground level where your car is parked. Now here the car is parked, and from this point the car is lifted in an upward direction. Now what is the mechanism behind lifting the car? So we'll see the Pascal's law is used in this mechanism. Now below this the fluid is there. This is fluid. If you observe, now we are going to lift this car, means this car is having some weight, that is weight of the car. We require some force. So where we are going to apply that force? On the other side, that is simple, the force F. So if we see that, if suppose this is area A1 and this is area A2, by looking this diagram we can say that area A1 is greater than A2. Means smaller cross sectional area is there, we need smaller force. So from the minimum effort we are going to lift the maximum load. That is the simple mechanism while lifting the car by the jack also. If we are taking the jack to lift the car, means we are applying the small effort and the maximum load we can lift. So this is the mechanism where the Pascal's law is used. Now how the Pascal's law is used? See, when the force is applied with a minimum force, this pressure intensity transfer that force in every layer, and it is transferred to the car also. From that it is lifted. So transmitted equally in a closed volume. Now this volume should be closed one. So you came across the different ideas or different terms also further. Now we'll move to the proof of Pascal's law. What we are going to prove? This one. Pressure intensity is same in any direction. So this is our proof. Now what the Pascal has done, he has taken the fluid element. This is the fluid element. Fluid element is a simple liquid drop, but Pascal has taken that fluid element in a triangular shape. So we are saying, we are given the name A, B, C. Now this side, that is horizontal side, suppose that is dx, vertical side, that is suppose dy, and the inclined side, suppose that is ds. This triangle is having an angle theta. Now what we are going to do, we are applying the pressure force. Now see the basic difference between intensity of pressure and intensity and pressure force. So we are saying that simply pressure P or intensity of pressure is equal to F divided by A. So this is pressure force, and this is simply the pressure, or we may also call it as intensity of pressure, and this one is area A. In a previous video we have discussed all these things. So now what we are going to do, we are applying pressure force on this element, fluid element. So if I am saying this is the pressure force, so for pressure force what is needed? Pressure intensity and area. So P multiplied by A, you will get pressure force. So pressure force means pressure intensity and area. So pressure intensity now is in a vertical direction. So we are simply writing it as Py. This is pressure intensity multiplied by area. Now this pressure intensity Py is acting on which area? This is length dx. This is length, but we need area. So imagine that this is having the unit width 1. So dx multiplied by 1 will have the area dx multiplied by 1. So now the total term is pressure force. In the same way, pressure force acting on vertical dy. So pressure intensity is horizontal px multiplied by, now this pressure intensity is acting on what part? Vertical part dy. Again same dy multiplied by this unit width 1 dy into 1. Now on this dx ds side, this is the pressure intensity dz, sorry pz. Pressure intensity is always perpendicular. Always remember, pressure intensity is always acting perpendicular to the surface. Now this is the surface and this is the pressure intensity, that is perpendicular Pz, but we need in terms of force. So Pz multiplied by this side ds multiplied by 1, unit width 1. Okay. So we can say that if this angle is theta, how much is this angle? This is also theta with the horizontal. This angle is theta. Okay. So now we are going to prove this Pascal's law Px, Py, Pz. Now resolve the forces horizontally. Means how many forces are there? 1, 2, 3. 3 forces horizontally. Now we'll start with this horizontal force. Now we'll first of all see the assumptions. Now what the engineering mechanics assumption says that the forces moving in a rightward direction, how they are moving you can analyze by arrow. If they are moving in a rightward direction, take it as positive. If they are moving in a leftward direction, take it as negative. If they are moving in a downward direction, take it as negative. And if they are moving in upward direction, take those forces as positive. So we'll start with this force that is moving in rightward direction, so positive, so plus, which is the force px multiplied by dy multiplied by 1. Now this force is vertical, so that is not considered into horizontal one, so neglect that force. Now this force is inclined force. Now we know that inclined force is having horizontal and vertical components. So we need horizontal component. So inclined force, we are now going to see the horizontal component that is moving in a leftward direction. So that is minus, because this component by this arrow, अगर आप इसको उठा के इधर रखेंगे तो ये इधर जाएगा. So minus what is the force? Pz ds multiplied by 1 is equal to 0. Sorry, this is inclined one. Now we need horizontal component. So ps ds into 1, this is the force, but this theta is also going to consider, so that is cos theta is equal to 0. Now if we again further see that ds multiplied by cos theta, so ds is this length ds, this one, and if we take the cos theta of this ds, you'll get the vertical side dy. So we may say it as ds cos theta is equal to dy. So we may write it as px dy minus pz, and this ds cos theta is dy is equal to 0. So you'll have like this px, so the dy get cancelled and you'll get px is equal to pz. Now we have resolved the forces horizontally by our engineering mechanics concepts. Now if we resolve the forces vertically, what will happen? See, resolve the forces vertically. Vertically means in vertical direction, either they are moving in upward direction or downward direction. Now this horizontal force is not going to consider because we are talking about vertically. So this one is considered because this force is vertical, moving in upward direction. We can analyze by this arrow. So py dx multiplied by 1, py dx into 1, but is in positive direction plus. Inclined force again is having two component, horizontal vertical. Horizontal component is considered in a previous case. Now vertical component is going to consider in this case. So if we take this force and keep on vertical plane, that is moving in a downward direction, so minus, because force is moving downward, so we are considering minus, so p z ds into 1, and this component is sine theta. Now how we have used this sine theta cos theta, you may going to learn in engineering mechanics how the forces are resolved. Okay, we are talking about vertically, means we should see this is the fluid element. This one is fluid element, and fluid element Pascal has taken in a triangular shape. So this fluid element is having some weight W. Now how we are going to calculate the weight? That is, we have seen in a previous lecture, is having a formula W, or weight, is equal to rho multiplied by G multiplied by volume. So rho is density of water, G is acceleration due to gravity, and volume is volume of this element. So volume you can calculate it, area multiplied by this width 1, area of triangle, that is half base into height. But we don't need this weight. Why? That is acting downward. But after solving this, Pascal again assumed that weight of this element is negligible. So he has not considered this weight in vertically downward direction. So directly he has taken 0. So we may write here minus W is equal to 0, but this W again converted into 0 component. Okay. Then after this we can see that dx sine theta, see this ds sine theta means horizontal component, so ds sine theta is equal to, we may write it as dx. So instead of ds sine theta, here you are going to write dx, so py dx minus pz dx is equal to 0, and at the last, that is py is equal to pz. So from this px is equal to pz and py equal to pz, we may conclude px is equal to Py is equal to Pz, that is our Pascals. Thank you.